So 6.2 talks about complementary events and probability of two independent events. What's a complementary event? It's basically saying the probability that something does not happen. They write it some fancy ways. I don't think our homework's going to write it these fancy ways, but they put like a little C up there for complement. But it's basically the probability of something not happening. So here's our first example. Suppose the probability of a horse winning a race is 0.15, also known as 15%, right? That's the chances that horse has to win that race. What would be the chances that they do not win the race? What is the total amount of like percentages available? It can only add up to 100%. If there is a 15% chance that it wins the race, what will we do to figure out what it does not win the race? Subtract 15 from 100. That would be 85%, which since they used a decimal, I'm going to use a decimal. That's probably the hardest part of our homework today is should I type it in as a decimal or should I type it in as a percent, right? We kind of got to read those little details carefully. So are we cool with that? It's just 1 minus the probability of that event happening. Easier one. On your weather app, it says there's a 30% chance of rain today. Cool. What's the percent chance it does not rain today? 70%, right? If there is a 30% chance it's going to rain, 100% minus 30% is 70%. Are you cool with the probability of an event not happening? Since it only adds up to 100, it is 1 minus that guy if he's a decimal, or 100 minus that guy if he's a percent. Cool? So, all right. Then here's the real meat and potatoes. Independent events are like where whatever event A is, event B has no effect on that whatsoever. Like the first event and the second event do not like have anything to do with each other. So suppose 60% of the people own dogs, okay, in this area. If you pick 2 people at random, what is the probability that they both own a dog? So we're not doing the complement. First person, here's what I'm going to do. Like I sometimes like to draw this out with blanks. So they were talking 2 people right here. What's the chances that the first person owns a dog? Not 50, it's 60%. First person owns a dog, 60%. I'm going to write that as a decimal, 0.60. What's the chances that the second person owns a dog? Does me picking the first person have anything to do with who the second person is? That answer is a no. So it was 60% for the first person. Second person will be 60%, right? The percent chance that a person owns a dog is 60%, and all we do is multiply those together. Sorry, I thought I had my calculator open. Could you please take 0.6 times 0.6 and see what that would be? Did you get 0.36 on that? So if they ask you to leave it a decimal, we'll leave it 0.36. If they wanted that to be a percent, are you cool with that? It's 36% in that case. All right? So those had nothing to do with each other. A die is rolled twice. What is the probability of it showing a 6 on the first roll and an odd number on the second roll? So here we go, 2 different events happening, right? So a lot of people like these blanks. You know, they're like, okay, they're going to do 2 different things. I'm going to put 2 blanks. First event is this. Probability, it shows a 6 on a dice. How many 6s are available? There is 1 6. How many possible things, though, on a die? So how do you feel about 1 out of 6? That is the probability of it rolling a 6. But then they have a second event, right? They're like, okay, then the next time I roll it, I want to roll an odd number, which is 1. 1 is an odd number, correct? 3, isn't 3 an odd number? And 5. Are you down with 1, 3, and 5? Aren't there 3 choices there out of 6, which that totally reduces to 1/2? All we do is multiply those together. Yes, you can use your calculator to take those fractions times each other. It's actually not that bad. You just take the top times the top. Do you know what 1 times 1 is? 1 times 1 is 1 over 6 times 2. What's 6 times 2, baby? 6 times 2. 12. Like if I didn't reduce it, you know, I would have had to use the 3 upstairs. So okay, let's see if it happens. What's the chances of rolling a die, and the first time it was supposed to be a 6, right? So here's my die, right? Here's my question. 1 out of 12 shot is what I got to do this. I want to roll a 6 the first time. The second time I want to roll an odd number. Do you think it's going to happen? Yes or no? The chances that it does happen is 1 out of 12, right? Very small percentage. Do you think it's going to happen to me? Let's try it. I'll roll the dice. I got to get to 6 on the first roll. Here we go. Fail. Didn't even happen on the first shot, right? The second shot was worthless in that case. So could it happen? Yes, it could. You know, there's a 1 out of 12 chances that that happened in that case. So cool. A coin is flipped 3 times in a row. 1, 2, 3. 3 times in a row. What are the chances that it turns up heads all 3 times? We have not talked about coins yet. Are we cool with heads and tails on a coin, right? Each one has what % chance of happening? 50%, right? So how about 0.50 to be a heads the first time? If I flip a heads the first time, does that have anything to do with the second time? No, it does not. Those are independent events. Isn't it still a 50% chance on the second flip, right? So second flip, 50%. And on the third flip, same thing, 50%. Guess what we do with all 3 of those numbers? We multiply them together. 0.5 times 0.5 times 0.5. And I got a 0.125, which is like 12.5% chance. I want to flip a coin 3 times in a row and see if I get heads. So here we go. This is just got heads up right now. I haven't flipped it yet. Is it possible? Sure is. I have a 12.5% chance of this working all 3 times, though. So first flip, I need heads. Fail. Didn't even get it on the first flip. Could it have been heads? You bet. Then I try again, and then I try again. I wanted to get heads 3 times in a row. Did you see that the percent was not very likely? You know, you had a 12% chance, basically, of getting that to happen. So not very likely. Same thing as guessing on a multiple choice. First of all, if you had no idea how to do a test question, but it was multiple choice, you should at least guess to give yourself a chance, right? If you don't fill in a bubble, you have a 0% chance of getting it right. But it says a quiz has 5 multiple choice questions, each with 5 choices each. So like A, B, C, D, E, you know, like those are your choices on it, right? And there's 5 of those. Steve didn't read the questions at all. He just went and guessed, you know, just filled them in. So 3 different questions. What are his chances of guessing correctly on the first question? So here's the first question. How many choices were there on the first question? 5. So that's like your total. You know how we're doing like want over total just like last time? Out of those 5 choices, how many of them were the right answer? Just one of them. Out of A, B, C, D, or E, one of them was right. We don't know which one, right, but one of them was right. Would you believe he has a 1/5 shot of just guessing on that, right? So we'll change that to a decimal also because I think the one on homework will have it be a decimal. So how about 0.2? Are we cool with that? We'll put both answers. He had a 0.2, 20% shot on it. What are his chances of guessing right on the first 2 questions? 1, 2. So we already did it for one question. He had a 1 out of 5 shot. On the second question, does answering the first question right or wrong have anything to do with the second question if you guess on it? Or is it still a 1/5 shot on the second question as well? Same thing, right? So 1/5. We can multiply those together. 1 times 1 is 1. 5 times 5 is 25. Would you believe he has a 1 out of 25 chance of that even happening, right? Which if we wanted that to be a decimal, 1 divided by 25, it would be 0.04. He went down to a 4% shot of just 2 questions guessing them correctly. And then what if he guessed on all 5 of them? 1, 2, 3, 4, 5. Each time he has a 1/5 chance of getting that right. And what I'd like to show you is how to type this in a little faster than like 5 times 5 times 5 times 5 times 5 times 5 times 5. Are you with me on that? So what I can do is upstairs is going to be 1 times 1 times 1 times 1 times 1. I hope we know that's still 1, right? But it's 5 times itself 5 times, so that's like raising it to the 5th power. You know, it's like 5 times 5 times 5 times 5 times 5. That's going to be a big number of 3,125. That's his chances of guessing every question right if he didn't read them. As a decimal, sorry, I hit the wrong button, 1 divided by 3,125. Nasty. It brings an E into the situation. E is scientific notation. Remember like times 10 to the negative 4th power or stuff like that? That means move that decimal 4 places to the left, so it's 0.00032. He doesn't even have a 1% shot. He's got a 0.032% shot. I'm pretty sure this is the answer to type in because that's easier to read than the snacky little decimal. But would you believe if I gave you a quiz with 5 questions on it, multiple choice, and you just guessed, you ain't getting them all right. Do you know what I mean? It's like, it's not going to happen. You can get some of them right, some of them wrong, but the chances of you getting them all right is very slim. 1 out of 3,125. If you did the ACT math test, right, which I don't know if you've taken or not, that's 60 questions with 5 choices apiece. So like if you guessed on every single one of them, there's 5 choices, 60 different times, you would have a 1 out of, I got to move that decimal 41 places to the right. That's probably like billions of trillions. Like you have almost no shot of getting them all right by guessing. You know what I'm saying? It's like, and that's a blind guess. You can always have a reasonable guess where it's like, okay, I don't think it's A, I don't think it's B, I don't think it's C, it's down to D or E. That gives you a different chance, you know. That's like 1 out of 2, you know, compared to 1 out of 5, right? So there's a difference between taking an educated guess and taking a blind guess, you know. So, all right. And then the last 2, you roll a special 7-sided die. What is the probability you roll a 5 or a 6? Probability is basically 1 over total. How many total sides are on this die? 7. We would like to roll a 5 or a 6, or means add them up, right? There's only 1 5, there's only 1 6, right? So how many total things could show up for us? 2. There's a 2/7 shot, which I think we'll probably just leave that as a fraction. You know, you can change it to a decimal if they ask us to, but 2/7. And then the last one of the day, man, basketball time. Remember, basketball, shooting a free throw is not a 50-50 chance. I know it's make it or miss it, right? But some people have skill. Yolanda is pretty skilled. She makes free throws 75% of the time, you know, because she plays basketball. So she is a 75% free throw shooter. She's going to shoot 2 free throws. Boom, boom. Cool. 2 free throws. The blanks really help on this, trust me, because this is kind of weird. Hey, when she makes when she shoots the first one, what's the chances that she makes it? 75%. Are you with me on that? So let's do that as a decimal, 0.75. So, all right, she had a 75% chance to make that one. She shot it. I don't care if she made it or missed it. Does whatever she did really affect what she did on the next one? Not mathematically, you know what I'm saying? So what's the chances that she makes the second one? 75%. We shall multiply those together, 0.75 times 0.75, and we will put 0.5625, 5625, and then you have to look on homework to see if they have a percent sign next to the answer box. So like if the answer box was right here, they may or may not have a percent sign to the right of it. If they don't have a percent sign, you put a decimal. If they do have a percent sign, you would have to move that guide. You see that's like 56.25% in that case. But that's the easy one. What happens if she wants to shoot 2 free throws, but she didn't make them both, right? On the first one, they say she makes it. What's the chances that she made it? 75%. And if she's got a 75% chance of making that free throw, what's the chances that she misses it? Doesn't that have to be 25%? You see how she missed the second one. So we'll multiply those together. 0.75 times 0.25, and that's 0.1875, which if they make you change that to a percent, that's 18.75%. So first one, she made it. I'm going to do this. You don't need to write this down. I just want to show it. Let's call X be a make. That would make more sense for miss. And O be a make. So first one, she made it. Second one, she made it, missed it. Are you with me on that? Made it, missed it. This one, what happens if she makes the first one, misses the first one, and makes the second one? So misses the first one, what's the chance that she misses it? 25%. What's the chance that she makes the second one? So are you cool that she had a 25% chance of missing it and 75% chance of making it? If I multiply those together, is that any different than those two numbers multiplied together? It's the same thing, right? So 0.1875, which is 18.75%. And what's the chances that she misses both? Miss. Hey, she's pretty good at free throws, right? You know, if it was a true basketball game, it's like, dude, Yolanda can make free throws. Do you think it's likely for her to miss both of them? Probably not. You think it's likely for LeBron James to miss both free throws? You know, he is really, really good, you know, so it is very unlikely. Two blanks. What is the chances that she misses the first one? 25%. What's the chances that she misses the second one? 25%. We multiply those together. And she has got a 0.0625, which is 6.25% chance. It is unlikely that she will miss both of them, but still possible. It is quite possible for someone to miss two free throws. So here's what she did. The possibilities we went through. Made them both, missed the second one, missed the first one, or missed both of them. Guess what? All of those percents add up to be. If I added 56.25% plus 18.75% plus 18.75% plus 6.25%, what do you think they would all add up to be? 100%. Because those are the only four things that could happen if you were at the line to shoot two free throws. You either make them both, make the first one, miss the second one, miss the first one, make the second one, or miss them both. That's the only thing that could happen. Shouldn't it all add up to 100% in that case? Cool. Let's do some homework.